So today we are going to look at lesson 3-2. And we are going to be working on a whole unit on radicals. So let's start with, before we look at square roots, cube roots, fourth roots, all that fun stuff, let's look at what perfect squares are. So a perfect square is a number times itself. So your first perfect square typically is 1. Well, technically it's 0, but we're going to go with 1. So 1 times 1 is 1. Excuse me. 2 times 2 is 4, so that's a perfect square. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. And the last one I can fit in here is 10 times 10 is 100. But you need to know yours all the way up to 15 times 15. So 11 times 11 is 121. 12 times 12 is 144. 13 times 13 is 169. 14 times 14 is 196. And 15 times 15 is 225. So make sure you know those. Then your perfect cubes are numbers times itself 3 times. So 1 cubed is 1. 2 to the third power is 8. 3 to the third is 27. 4 to the third is 64. It's a popular one. 5 to the third is 125, another popular one. 6 to the third is 216. 7 to the third, 343. 8 to the third, 512, and 9 to the third, 729. And we'll stop there. Your perfect fourths, that means the number times itself 4 times. So 1 to the fourth is 1. 2 to the fourth is 16. That's a very popular one. 3 to the fourth is 81. Another popular one. 4 to the fourth is 256. 5 to the fourth, 625. That's also 25 times 25, another popular one. 6 to the fourth is 1,296. 7 to the fourth is 2,401. And we're going to stop at 8 to the fourth, which is 4,096. Okay, so now as we get into radicals, let's talk about the parts of a radical. So as I use vocabulary, you need to know what I'm talking about. So this root that we're taking is an index. So I've actually heard it called both ways, so it doesn't really matter which one you use, but technically it's an index. You'll also see the word root. Then this symbol right here, not this because that's the index, this symbol right here is just the radical. And then the number underneath the radical right here, that is your radicand. Now, if there is no number here, it just looks like this. It's assumed that it's a square root and that n is equal to 2. Whoops. I chose the wrong pen. All right, so let's give possible, when it says give all possible roots, that's important verbiage. So if it says all possible roots, and I asked you to give me the square root of 16, most of you would say 4. Well, that's 4. Because 4 times 4 is 16. What number times itself twice gives you 16? Well, there's also another number times itself that gives you 16, and that's -4 times -4. So technically, the square root of 16 is both +4 and -4 because those are all the possible roots that could multiply by themselves to give you 16. So then what number times itself twice gives you 121? That would be 11 and -11. 289 that would be 17 and negative 17. When you take the square root of a fraction, you take the square root of the numerator and the square root of the denominator. So the square root of 4/25 is 2/5 and negative 2/5. Then we're going to move to cube roots. So a cube root just means what number times itself 3 times gives you 8. Well, that's 2 times 2 times 2. So the cube root of 8 is 2. Now I want to put that in a different color. How about 2? Now, you cannot say negative 2 because negative 2 times negative 2 is positive 4, and positive 4 times a negative 2 is negative 8. So the cube root does not have 2 roots. A cube root only has one answer, because an odd number of negatives is going to give you a negative, not a positive. So whereas an even number of negatives gives you a positive, just like a positive does. All right, so what number times itself 3 times gives you 400 or 343? Well, that would be 7. What number times itself 3 times gives you negative 125? Well, that's going to have to be a negative 5 times negative 5 times negative 5. So your answer to that one actually is negative. So if the number under the radical is positive and it's an odd root, you can have a positive answer. If the number under the radical is positive, odd root, positive. But when the number under the radical is negative and you have an odd root, note that you have a negative answer. You cannot take an even root of a negative value. Reason being, if this were a negative 16, there is no number times itself twice that gives you negative 16. 4 times 4 is a positive 16. A negative 4 times a negative 4 is a positive 16. So then I have kids tell me, well, then it would be 4 times negative 4. Well, that's not the same number times itself. That's 2 different numbers, so that doesn't count. So you cannot take an even root of a negative number. It's not possible. All right, so on this one you have, let me quit moving it on you. We have an odd number with an odd root, a negative number with an odd root, so our answer is going to come out negative. So I already know that much. And then the cube root of 1 is 1, and the cube root of 27 is 3. All right, you find the fourth roots of these on your own, pause the video, and then turn it back on. All right, so the fourth root of 1 is 1. The fourth root of 2,401 is, and negative 1. I'm sorry, I forgot about that. It's an even root. Isn't negative 1 times negative 1 times negative 1 times negative 1 gives you positive 1? So remember, every even root has 2 possible answers. So the fourth root of 2,401 would be 7 and negative 7. The fourth root of 4,096 would be 8 and negative 8. And then the fourth root of 81 would be 3. The fourth root of 16 would be 2. And because it's an even root, we also have negative 3/2. So to sum it all together, in this table right here, if you have an even index, 2, 4, 6, 8, so forth, and the number under that radical is positive, you're going to have 2 real roots. So you're going to have 2 real roots. Well, there is such a thing as an imaginary root, one that doesn't exist, and we're going to talk about that in a minute. Then, if you have an odd index like 3, 5, 7, 9, and the number under the radical is positive, you are going to have 1 real root because it's going to be a positive answer. So 1 real root. If you have an odd index, 3, 5, 7, 9, etc., and the number underneath that radical is negative, you will have 1 real root, and that's going to be negative. So let's put on here what the sign of the answer would be. So over here, you would have a positive or a negative sign because you have 2. Over here, you would just have a positive, and here you would have a negative answer. So then the last one says, and it's starred for a reason, if you have an even root, 2, 4, 6, 8, so forth, and there's a negative number under there, you actually don't get a real answer. So like for instance, if I had the square root of negative 16, so that's an even root, but there is no number times itself twice that gives me a negative 16. It's just not possible. So we call that kind of an answer an imaginary answer. And we are actually going to end up getting 2 answers for that. You will learn about that in a later unit. And those answers are going to also be positive and negative. But we'll talk about the set of imaginary numbers later. The answer to this is actually positive or negative 2i. But we'll get into that later. Okay, so look at the change in directions. It says if a radical has more than one root, meaning it's an even root, it has a plus and a minus, the radical sign indicates only the principal or positive root. So because I'm asking for the square root of 117, I only want the positive answer. I don't want the positive and the negative answer. Now if I put a plus minus in front, then I want both. If I put a minus in front, then I want the negative answer. But otherwise, I just want the positive. All right, so to figure out, 117 is not a perfect square. So if you throw it into your calculator, you're going to get a decimal. So you have to figure out how to simplify it on your own. So I would suggest that you prime factor each of your numbers. I gave you a divisibility sheet. And stretch out those numbers, and we're going to just take groups of whatever the index is. So 117 is going to prime factor into, so I know that 9 divides into there, and it goes in there 13 times, and 9 can be converted to 3 and 3. So underneath this radical, I really have 2 3s and a 13. So because my index is 2, I can circle groups of 2 and pull one of them out in front. So they're both going to disappear. And if you think about it, if I cover this up, this is the square root of 9, because 3 times 3 is 9. So what's the square root of 9? 3. So I'm going to circle these and bring out just a 3 out in front, and the 13 is going to stay underneath. So I'm going to circle a group of 2 and bring that 3 out in front. I'm circling a group of 2, or a pair, because my index is 2. And then this 13 will get left underneath. So your final answer is 3 square root of 13. Okay, so let's make these really big so I have plenty of room. All right, so this one has a number in front. We're still going to factor this. So 32, or 320, is 32 times 10, 4 times 8, 2 and 2, and 8, you will come to learn, has 3 2s, because we factor that a lot. And then 10 is 2 and a 5. So underneath, well, actually in front, I have a 4. And I have the square root of 2, 4, 6. Okay, so I am going to circle groups of 2. So I've got 1, 2 coming out in front. I'm going to multiply that 2 to the 4. A second 2 coming out in front. I'm going to multiply that to what's out in front. And a second group of 2 out in front again. I'm going to multiply that out in front, and the 5 is left over. So I have a 2 times 2 times 2, which is 8, times 4 is 32. square root of 5. Now you pause the video and try this one on your own. So if I factor this, I get 4 times 12. And so I end up with 2 cube root Now this one, instead of a square root, it has a cube root. So we're not going to circle groups of 2 because we want what number times itself 3 times. So I'm going to circle groups of 3. So you're going to see me circling a set of 3 2's and bringing that out in front to multiply to the 2 that's already in front. I can't make any more groups of 3, so you're going to have to leave the 2 and the 3 underneath the radical. So multiply out the 2 times 2, which is 4, cube root of, and then you want to multiply what's left underneath here. 2 times 3 is 6. All right, then number 4. That one you should be able to do on your own. So go ahead, pause the video and do it. Just do it. So 9 goes in there once, twice, 3 and 3, 3 and 4, 2 and 2. So I have a 3 cube root of 2 2's and 3 3's. So because we have a cube root, we want to circle groups of 3's, so it can only make one group of 3. Pull out in front, and it gets multiplied to the 3 that's already out in front. The 2 2's, I can't make a group of 3, so I'm going to leave that underneath. And so I end up with 3 times 3 is 9 out in front. Cube root of 2 times 2 is 4 underneath. All right, so let's look at this back page. So number 5. So this time we have a cube root of a negative number. So we're going to pull out a negative. So that negative attached to the 250, you're going to take it out. Let me use red. You're going to take it out as a negative 1 times 250. We'll talk about that in a minute. Then 250 factors into 25 times 10. And we got 5 and 5. And 2 and 5. So this equals the cube root of negative 1 times 2 and then 3 5's. So I'm going to actually take out this negative 1 out in front, because if you ignore all this, the cube root of negative 1 is negative 1. I could have written the negative 1 3 times because of that index, but I just didn't feel like it. So negative 1 times negative 1 times negative 1 is negative 1. So it is a perfect cube. So that's why I am taking it out in front. And it doesn't actually look like it's a group of 3, but it is. So anytime you have a negative underneath an odd root, just take it out in front. Then I can take a group of 3 5's out in front and multiply that to the negative 1, and then the 2 gets left underneath. So the 5 and the negative 1 out in front multiply to give you 5. Cube root, the 2 is left underneath. Number 6. So same thing with number 6, except for the only thing you can factor with the 2 is you can factor that negative 1 out from the 2. So you get 6 cube root negative 1 times 2. So that negative 1 is coming out in front because it's a perfect cube, and it gets multiplied to the 6. So negative 1 times 6 is negative 6. Cube root, I cannot make the 2 into a group of 3, so it stays underneath. number 7. So I want you to factor 7 on your own and then check the video for your answer. So if you factor this, you get, let's see, 9 goes in there, 18 times, okay, so I have a 3 4th root of a 2 and 4 3s. So my index is 4, so I want groups of 4. So there's only one group of 4 I can make, which is right there. That's going to pull out in front as a 3. So that 3 gets multiplied to the 3 already out in front. So 3 times 3 is 9. 4th root, that 2 gets left underneath. Now don't let 2,592 intimidate you. 2 plus 5 is 7, 7 plus 9 is 16, plus 2 is 18, that's divisible by 9. So is 2,592 then. So I'm going to divide this by 9. So 9 goes into 25 twice, 7 left over. 9 goes into 79 8 times with 7 left over, and 72 8 times. So this becomes 3 and 3. And I know that 288 is divisible by 4, so 4 goes into 28 7 times and into 8 twice. And 72 is 9 times 8. Whoops, 9 becomes 3 and 3. And 8 is 3 2s. So that gives me a 5 out in front, 4th root of, I've got 2, 4, 5 2s, and then 4 3s, so I think I got them all. Okay, so I'm looking for groups of 4 because that's what my index is. So here is a group of 4. So I'm going to pull a 2 out in front, and I can make another group of 4 with these 3s. So I'm going to pull a 3 out in front, and all I have left over is a single 2. So out in front we have 3 times 2 is 6, 6 times 5 is 30, 4th root of 2. Now we're going to throw some exponents into the mix, or some variables with exponents. So let's keep a few things in mind. So if I'm going to take the square root of a power, which is a base with an exponent, the exponents must be multiples of 2. If I'm going to take the cube root of a power, the exponents must be multiples of 3. And if I take the 4th root of a power, my exponents must be multiples of 4. What does that mean? So let's look here at number 9. So we spent a lot of time with numbers. So you're still going to go ahead and prime factor the 32. And you'll soon learn that 32 has 5 2s in it. Always. Never changes. So you could do this 2 ways. And I'll do it 2 ways this time, but I know which way most of you are going to prefer. So you could stretch out your 2s. But then write your x to the 4th times y to the 9th out here. So because my index is 2, I am taking groups of 2. So I'm going to pull 1 2 out in front and a second 2 out in front. And then that leaves me a 2 here. So I've got 4 square root of 2. Now, here's how we deal with the power. So your variables are bases raised to an exponent, so that's a power. You're going to take your index here, and in this case, the index is 2 because we cannot see it, right? You're going to take that index and divide it into the exponent. So on one of these, I'm going to divide both of these by 2. That's our index. That's why we're dividing by 2. Now 4 is divisible by 2 equally, twice. So 4 divided by 2 is 2. So we're going to bring out 2 x's out in front. So we end up with an x squared out in front. And if you think about it, I could stretch out the x's into x, 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 and x, so 4 x's. And I could circle a set of 2 and a set of 2, so I'd have 2 sets of 2. And an x would come out from each of those sets, making x times x is x squared. This is a shortcut to stretching out the x's, because who wants to stretch out 9y's? I don't. So this is a shortcut. So 9 divided by 2 does not go in there evenly. So if you look at long division, 9 divided by 2, 2 goes into 9 4 times evenly. 4 times 2 is 8, giving us a remainder of 1. So that means we're going to have 4 y's come out in front, so we'll have y to the 4th, and that remaining 1 y will come down below. And if you think about it, if you stretch out 9 y's, you're going to be able to make 4 sets of 2. 4 sets of 2 is 8 y's with 1 y remaining. So this is your 8 y's, this is your 8 y's, because it was 4 sets of 2. So 4 sets of 2, that's what that represented, was your 8 y's. You only took 1 y from each of the 4 sets. And that was your remaining y. Sorry, I was stretching. It's been a long day. All right, look at number 10. So we're going to prime factor. Oh, I told you I was going to do this 2 different ways. So what's the other way? So the other way would be, what if I put my numbers into power form as well and use that index rule? So what if I had the square root of, I had 5 2's, so 2 to the 5th, x to the 4th, y to the 9th. Then you could divide your index here is 2, so I could divide this by 2, 2, 2. So 5 divided by 2, 2 goes in there 2 whole times with 1 remaining. So I would have 2 whole times with 1 remaining. So this is my radical. So again, 5 divided by 2, 2 goes in there 2 whole times. 2 times 2 is 4. That leaves 1 left over out of 5 that goes underneath. Then 4 divided by 2 goes in there evenly twice. So I'm going to have an x squared out in front. Nothing remaining underneath for the x's. 9 divided by 2 goes in there 4 whole times. So I get y to the 4th. Then 4 times 2 is 8, leaving 1 y left over out of 9 that has to remain underneath. And so 2 squared is 4, x squared y to the 4th, which is the same as this, with the 2y. So it doesn't matter which way you do it, you should get the same answer. So for number 10, I want you to try that one on your own. So I'm going to stretch these out. I have 2 2's and 4 3's. Again, you could write them in power form. I'm definitely writing the variables in power form. And then I'm going to look for groups of 2 because I have an index that's 2. So I'm going to take out a pair of 2's, a pair of 3's, another pair of 3s, and then, so I don't have any numbers left over, then I'm going to divide each of these by 2. So 3 divided by 2 is 1, so I have 1a coming out in front with 1 remaining underneath. 7 divided by 2 is 3, so I have b to the third, and then 3 times 2 is 6, that leaves 1 left out of 7, so you should have 1b left underneath. So multiply what's out in front. 2 times 3 is 6, 6 times 3 is 18, ab cubed, square root of ab. All right, we're going to prime factor again. So 216 is divisible by 9. Goes in there 24 times. Okay, so I have the cube root of 3 2s and 3 3s. And then m to the third, n to the sixth. So I've got an index of 3, so I need groups of 3. So here's one group of 3, comes out as a 2. A second group of 3 comes out as a 3. Then I'm going to divide this by 3, and 3 goes in there evenly once, so I get m to the first. 6 divided by 3 goes in there twice, so I get n squared, and there is nothing left over. So my answer is 6mn squared. All right, so let's look at 12. So for 12, we are still going to prime factor 56. So all of these have a common thread. So 7 times 8 is 56, and then 8 has 3 2s. So stretch out your numbers. And then your powers. So because your index is 3, I'm going to take a group of 3, so 2 comes out in front. The 7 is going to stay underneath. Then your index is 3, so you're going to divide your exponents by 3. 8 divided by 3 is 2, so you're going to bring out 2 r's. Then 2 times 3 is 6, that leaves 2 remaining that go underneath here. So r squared remains underneath here. Then divide your 4 by 3. 3 goes in there one whole time, so 1s is coming out in front, and 1 times 3 is 3. That leaves 1 left over out of the 4, so we have 1 remaining underneath. For 13, you have an odd root with a negative value underneath, so automatically the answer is going to be negative. So if you prime factor 64, stretch out, you got 6 2s. And then x to the 10th, y to the 21st. So pull out a group of 3, so 2 comes out in front, another group of 3, another 2 comes out in front, so there's no numbers left over. Divide 10 by the index of 3. 10 divided by 3, 3 goes in there 3 whole times, so x cubed comes out in front. So then 3 times 3 is 9. That leaves 1 left out of 10. So underneath the cube root is 1x. Divide 21 by 3, and it goes in there evenly 7 times, so you're going to bring y to the 7th out. Then multiply the 2 and the 2 together, so you get 4. x cubed, y to the 7th, cube root of x. So you do this one on your own. It's just like the previous one. And then pause the video and restart it. So remember, oh, wait, I forgot. Totally forgot. If you go back to 13, because of that negative, right here, I should have pulled a negative out in front of here. Remember I said your answer was negative? Sorry. So back to 14. See, if I force myself to pull a negative out from the beginning, we won't have that issue. So stretch everything out. All right, so I'm looking for groups of 3. This -1 is coming out because it's always a perfect cube, a perfect nth root of anything. So the cube root of -1 is -1. Then I can make one group of 3's come out as a 3. So that 3 will be left over under the cube root. I cannot divide 2 by 3. It doesn't go in there at all. So no p's are coming out in front. So both p's will be left underneath. When I divide the q by 3, it goes in there evenly 4 times, so I get q to the 4th out in front and nothing left underneath. So multiply everything in front, you get -3 q to the 4th, cube root of 3p squared. Last 4. So this one just has variables, so I'm not going to have to prime factor anything. So I'm just going to divide each of the exponents by the index. So 4 divided by 4 is 1, so 1w comes out in front, nothing left over. 17 divided by 4, 4 goes in there 4 times, so v to the 4th. So then 4 times 4 is 16, that leaves 1 left over out of the 17. So I do have underneath the 4th root a single v. Then prime factor the 48. 6 times 8, 2 and 3, and then 3 2's. So I've got 4 2's and a 3, m to the 8th, n to the 3rd. So I'm taking groups of 4, so I've got one group of 4, 2 comes out in front, the 3 is left underneath. Divide the 8 by 4, because that's my index. 4 goes in there evenly twice, so I've got 2 m's that come out in front, no m's left underneath. The 3 is not divisible by 4 at all, so no n's come out in front, and all 3 n's will be left underneath. All right, so 17, 625 is 25 times 25. And then we have c to the 23rd, d to the 11th. So because my index is 4, I'm taking a group of 4. So a 5 comes out in front. Divide 23 by 4. 4 goes into 23 5 times evenly, so c to the 5th. So then 5 times 4 is 20. That leaves 3 left over out of 23. So you've got c to the third left underneath. Divide 11 by 4. 4 goes in there twice, so you get d squared. 2 times 4 is 8. That leaves 3 left over out of 11. So d to the third is left underneath. And our last problem. So this one's a more challenging problem, but you can pretend as if this is no different than having a z to the 8th here. So this is the base, that's the exponent. So we're just going to take the index and divide it into the exponent. And so 8 is divisible by 4 2 times, and that's even, so I'm going to take out in front a y plus 3, because 8 divided by 4 is 2, I take out 2 of those. No remainders, that's your answer. Good luck on your homework. If you have any questions, let me know.